All right, good morning, everybody. We're going to be doing constant rate of change this morning. I'm going to kind of walk through this page. I'm on page 23, and then I'm going to go through a couple examples on page 24. Okay? At any time, if you want to pause this video, feel free to do so. Starting with up top, the examples, the reteach that they give us, it says a proportion is an equation or statement that two rates are the same. In 1 hour of babysitting, Rajiv makes $8. He makes $16 in 2 hours and $24 in 3 hours. So they took this information and they put it in a table below. They said time worked in hours and their total wages in dollars. Okay, so we are used to this table, or at least we should be by now. I've taught it in class. Remember, the top numbers are X values, the bottom are Y's. Same thing if there was a table vertically. So if they had it this way, divide in half. Let's see. There's 1, 2, 3. 1, 2, 3. Okay. So same thing if we had 1, 2, 3, and then 8, 16, and 24. Okay. The left would be our X values. The right would be our Y. Okay. So to see if this relationship is proportional, find out if the rate of change is constant. Express each rate of change shown in the table as a fraction. So here they put their fractions. We have 8 over 1, 16 over 2, and 24 over 3. In other words, 8 divided by 1, 16 divided by 2, and 24 divided by 3. If you take a look at each of these equations right here, what do you notice? Which number is our numerator? Which value is our denominator? Do we have x divided by y or y divided by x? Okay, so go ahead, take a look, see what they're doing. If we look down here, it says the rate of change for each column is the same because the rate of change is constant. The relationship is proportional. This is key right here. Okay, if you have a highlighter, go ahead and highlight it. Or you can circle it just as I'm circling it. Okay, this is key. So we know it's proportional because the rate of change is constant, meaning that all of our answers right here are the same. That means we have a constant. It's similar, okay? If we take 8 divided by 1, it equals 8. 16 divided by 2 equals 8. 24 divided by 3 equals 8. Because all three of our answers equal 8, we have a constant rate of change. Okay? We can express a proportional relationship by using the equation y equals k times x, where k represents the constant rate of change between x and y. Okay, that's, again, another key component. We went over this in class. But as a reminder, again, k represents the constant rate of change between x and y. In this example, k equals 8, so in our equation, we would write y equals 8x. Okay, again, our formula, if we forget, so in order to find the constant rate of change, so in order to set it up here, they took their y values right here, so their y value of 8, and they divided it by x of 1. So we have k equals y divided by x. That's our formula, okay? So if we look here, total wages, 16, we have our value of y, 16. We would place right there, divided by our x value of 2, which is what they did here, 16 divided by 2, which equals 8. If we were to do it in a vertical table, it'd still be the same thing. We have our y value of 8, you plug in 8 right there, divided by our x value of 1, which would be placed as the x value of 1. So we would have 8 divided by 1, and that will give us our constant rate of change. As you can see here, they did it 3 times for all 3 problems, and each of them equals 8. So that example is a proportional relationship because they have a constant rate of change of 8. So if we look here, it says the table shows the number of texts Terry received in certain periods of time. Okay, again, time, these are our x values. Number of texts would be our y values. So kind of take a look at our example here. Here's the formula, k equals y divided by x. Utilize this, okay? Number 1 says, is the relationship between numbers of text and time a proportional relationship? Well, how do we know if it's proportional? If we look back up here, the rate of change for each column is the same because the rate of change is constant. So when you answer all of these, when you divide them up using this formula, are all your answers the same? That means it has a constant rate of change. For number 2, for each column of the table, write a fraction and find k. So here you're just showing your work. 3, express the relationship in the form of an equation. So that's this, y equals ax. All they're using is this formula right here, y equals k times x. And then what is the rate of change? So this is saying what is k? Pretty much k equals what? This is y equals what times x. And then this is showing your work in order to find the constant rate. Here it says write the equation for each table, let x be time or weight. So x is time and x is weight, which means y is distance and y is cost. Okay, again, make sure you use this formula, k equals y divided by x, in order to solve for your constant rate to see if it is proportional or not. If you turn to the back on page 24 now, the constant rate of change, so it says use the table to determine whether the relationship is proportional. If so, write an equation to show the relationship between the two quantities. Tell what each of the variables you use represents. The first one has been done for us. So we have teams, 1, 2, 3, 4. We have 1 team, 2 teams, 3, and 4 teams. And the number of players. So for 1 team, there's 6 players. For 2 teams, there's 12. For 3 teams, there's 18 players. And for 4 teams, there's 24 players. Okay. It asks, is this proportional? They said yes. Well, how do we know? If we were to check their work, if we flip over, we use our same formula, k equals y divided by x. So teams is x, players is y. K equals y divided by x. So I'm going to say k equals 6 divided by 1. So we get 6 here. 12 divided by 2 equals 6. Then we also have 18 divided by 3, which equals 6. And 24 divided by 4, which also equals 6. So because each of my answers are 6, my rate of change is 6, yes, it is proportional. Why? Because if we look back, it says the rate of change for each column is the same, which my answers were all 6s. So because the rate of change is constant, the relationship is proportional. So again, I have a constant rate that is the same, so it is proportional. So yes. So my equation would also be y equals k times x. Oops, k times x. Sorry, it's really sloppy. Y equals k times x. Okay, so my equation, well, what is k? K is 6, so all I did was replace k for 6, so y equals 6 times x. And then C, number of teams, that is my x value, so x represents teams, and y value represents number of players. Okay, so you're going to do the same thing for number 2, 3, and 4. Okay, for number 3, please do not let the decimals confuse you. Okay, you're still doing the same steps. You're going to take your y divided by your x and see if you still get the same decimals. Okay, so if we set it up, it would be 2 and 25 hundredths divided by 3. If we take a look here, 2 and 25 hundredths divided by 3, we get 75 hundredths. So equals 75 hundredths. So now I want to make sure that these two also equal 75 hundredths. If we do, then it's proportional. All right, and for 5 and 6, it says the following tables show proportional relationships. Find the constant of proportionality, k. Then write an equation to show the relationship between the two quantities. Tell what each of the variables you use represents. The first one has been done for us. So if we take a look, apples and bags, it says we have 5 apples for 1 bag, 10 apples for 2 bags, 15 apples for 3 bags, and 20 apples for 4 bags. They found their constant rate of change was 1/5. So they took 1 divided by 5, which is 1/5. And then here we get 2/10, but 2/10 can be reduced to 1/5 by dividing it by 2 to get 1/5. We have 3/15. Okay, 3/15, that can be reduced to 1/5 by simply dividing by 3. And 4/20, which can be reduced to 1/5 as well. So yes, they all have a constant rate of 1/5. Then they have their equation, and they labeled what the values represent. So X represents apples, Y represents bags. So you guys are going to do the same thing here for cartons and eggs. Okay? If you have any questions, please let me know. Tomorrow we should be posting on proportional relationships and graphs. Okay, do the best you can. If you want to move ahead and then look back at the videos, please do so. Okay, challenge yourselves. Have a great day.